Hello everyone, welcome to the session. So in this particular session, we will talk about another interview based problem, which is completely based on the concept of a binary search that we did in our previous videos, right? So the expectation from you all is that you already have watched those videos before coming to this session, right? Now this is one of the vastly asked, frequently I would say interview based question in many of the product based companies. Try to understand this question. I hope we all know now that what is two-dimensional matrix or what is 2D array, right? Where we have specific rows and the specific columns, right? So what this particular question is saying, this question is, you can see that this similar question is available in LeetCode platform as well. So here what they want to say is that we have been provided a 2D matrix. So user will provide some 2D matrix. In that, the two major points are there. So 2D matrix will be of size m cross n, where m is the number of rows, that we have, right? And n is the number of columns. Here, if you will try to see this is nothing but 3 cross 4. So I can say that the value of m in our example is 3 and the value of n is equals to 4, correct? Now, what the question says. So here by default it will start from 0, 0, 1, 2, 0, 1, 2 and 3. Now the question says two important points which I have already written on the blackboard. Here the first point says that the values which are given to you in a 2D matrix will be in a sorted fashion from left to right. So here the sorting will be done from left to right. So here if you will see, all the elements in each and every row is in a sorted fashion. 1, 3, 5, 7 sorted. 10, 11, 16, 20 sorted. 23, 30, 34, 60 again sorted. So here all the elements that we have in the matrix is in a sorted fashion. This is the very first point. The second important point is that if you will try to compare the first integer of every row, so first integer of each row is having a value which is higher as comparable to the last integer of the previous row. If you will compare the 7 and 10, 10 value is higher as comparable to 7. Again, if you will compare 20 and 23, the value of 23 is higher than 20. So first point says row wise it will be in a sorted fashion. Every row, whatever user will provide, will be in a sorted form. Second point says that the first element present in each row will be having a higher value as comparable to the last integer which is present in the previous row, which we can see in the example as well. Okay, that's fine. Now I hope everyone wants me to speak up about the problem statement. So problem statement says that given a target value, suppose I am saying that the target is somewhere equals to 3. So my code will return either the value as true or false, okay? By saying that, suppose if 3 is already present in the matrix which is given to us by the user, 2D matrix. So if 3 is present inside this 2D matrix, so output should be true. So in this example, because 3 is present, so output should return as true. Suppose I will type some random value, the target value is something which is not available in my 2D matrix. For example, if I am writing 22, in that particular case, it should return me the value as false. It should return me the value as false. So here if you will see, what we want as a final result is a Boolean value which is either true or false. If the target is available in the 2D matrix, which is a sorted manner in a row wise, at that point of time, it should return the value as true. Otherwise, it should return the value as false. That's the overall idea behind the given question which is given to us. I hope I'm making sense. Now, what should be the approach that we should think of? I think brute force approach is very simple, which I think everyone is able to understand. What should be the brute force approach for this question? Anything which you can think of? Brute force approach, naive approach also is the other word which I can say here. Means very first thing which is coming to your head, like how we can solve this problem. You will say to me that you can do one thing, Priya. Here you can start from the starting of the value, and you will try to scan all the matrix step by step, and you can just compare each and every element with the value which is you are comparing with. For example, your target is 3. So what you can do is that you will start from 1. You will just simply compare the value of 1 which is equal to 3. No, I will move ahead. It is equal, I can return. Maybe if I am looking for a target value which is equals to 60, at that point of time, what will happen is that it will again move ahead, 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 move ahead. Finally, we got the answer. Finally, the 60 is there. So it will return to me the value as true at that point of time. So what I want to tell you here is that the brute force approach is that where we can scan all the elements that we have in a 2D array. How many number of elements do we have? It will be equals to m cross n, right? 3 cross 4 means in total we will be having a 12 elements. So can I say that in a brute force approach, when we are trying to scan all the elements step by step in a linear fashion, the time complexity will be nothing but is equals to order of m cross n, right? Because here we need to apply 2 for loops. One for loop will take care of the rows for I equals to 0 to m, right? For I equals to 0 to m minus 1, I would say. And internally there will be another for loop which will start from 0 and will run until the number of columns. And then it will try to pick up each and every element. And we are trying to say that if the value of the array of I and the j is equal to the target value, we are saying just return maybe the value as true. Otherwise, if suppose you completely scan all the for loop, all the rows and columns, simply you can return the value as false, which indicates that there is no element which you are looking for is present in your 2D matrix. So this is a kind of approach where we are applying 2 for loops. One will run until m number of times, another will run until n times. So for each and every value, the value of j will start from 0 and will run until n minus 1 number of times. So here, overall, in a brute force approach, what we can see is that the time complexity will be order of m into n. Now the next question which I will ask from you is that instead of scanning each and every element, just like the way I showed you, where we are traversing 0, 0, 0, 1, 0, 2, 0, 3, then 1, 0, 1, 1, 1, 2 and 1, 3, then 2, 0, 2, 1, 2, 2 and 2, 3 via these 2 for loops, are we able to do something which will be having a lesser time complexity as comparable to this order of m cross n? Can we do something here? What do you think? Here if you will observe, can we write this same 2D matrix in the form of a virtual array, where consider that the indexes will be something. So consider that there is a virtual array whose index will start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Means there is no original array that I am talking about. I am talking about consider that there is a 1D array whose values will start from 0 and will end at 11. At that point of time, if I will write those numbers itself, so here I was having the numbers in a row wise, in a row major form. I am trying to write it down. And then because I know that the rows are in a sorted fashion, and even the last element which is present in each row is having somewhere a lesser value as comparable to the next row first element. So if I will write the complete matrix in such a way that, just see this. So here I am having the value as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So here index number will start from 0. It will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So the elements that we have were 1, 3, 5, 7, 10, 11, 16 and 20, 23, 30, 34 and 60. And the target value that we have is something which is equals to 3. So now if we have this kind of array where the target value is given to you, how can you optimize your code? You can easily apply binary search. Can I say? You can easily apply a binary search on this kind of an array. But here the question is that the array is not like this. We have a 2D array, but here I just make it down as a row major form. That also I am saying it's a virtual array. It's not that originally in an extra space we are doing so. Then how basically we will be able to get what is the row number and what is the column number of each and every element that we have? There is a formula for that. Now try to understand this part. We all know how binary search will work. So if we have this kind of an element, so basically what we need to find out is the middle value. Now middle value will be 0 plus 11 minus 0 divided by 2, which is equals to 5. So this is something which is equals to mid here. Now I have to find out that for this particular mid index, which is 5, what is the actual location in my 2D array, because that was the question which is given to me. So here, what is the number of columns that we have? It is equals to 4. So always remember that you will be able to calculate the corresponding row for any element will be equals to whatever the index number that you are getting divided by the number of columns that you have. So here it will be equals to 1. Similarly, you can be able to get the value of the column for that particular index, that will be equals to 5 modulo 4. 5 modulo the number of columns that you have. So here it will be equals to again 1. It means it is saying to me that go to the row number 1, go to the row number 1 and go to the column number 1. You will be able to get 11. And that is so true. When I am moving towards row number 1 and the column number 1, I got the element as 11. Now, whatever operations I am doing is on the original 2D matrix. But the way I am explaining to you is like something is happening on this virtual array. Here, again, what element I am looking for is 3. Now, I am looking for an element which is less than the mid value. So I should go towards left or right? I should go towards left. It means that the value of my right as of now will become mid minus 1, right? And the initial index left is equals to 0. In this particular case, it means that now we need to traverse towards this whole area. Again, I will try to find out the middle value. Now the middle value will come out to be 2. Now the middle value will come out to be 2 because 0 plus 4 divided by 2 is something which is equals to 2 only. Now again, the element, what is the element corresponding to this 2 index? What is the row number? Row number will be equals to 2 divided by 4. So it will be equals to, what will be the value? And what is the column number? It will be 2 modulo 4. Now, here if you will go towards this 5 element, here if you will see 0 and 2, and this is what you are getting here. 2 divided by 4 is 0, 2 modulo 4 is 2, and that is what you are getting here. That is what you are getting the location of 5. It means that we will be able to extract any of the element by calculating the row number and the column number, and we can apply the binary search approach on this particular matrix as well. So here we are optimizing our code from order of m into n to, because binary search will take order of log of n, and here we are dealing with the elements of m cross n. So here you are reducing your time complexity from that sense, from order of m cross n to order of log of m into n. Again, what will happen? The target value is 3. Still it is less than the value which you are looking for. So again you will go towards the left side. Now again you will evaluate what is the mid value. Mid will be equals to 0 plus 1 divided by 2. Again it will be equals to 0 plus 1 divided by 2 is 0, right? We will take the lower bound of that. So it will be 1. So now what will happen? It will go towards right side. Only 3 is there. So left is also 1, right is also 1. So middle will be 3 and target is also 3, so it will return the true value. This is how basically we will be able to solve this problem. So in a nutshell, what we are trying to do is that given a 2D matrix, we are trying to generate a virtual 1D array whose index will start from 0 and will go until the last element, which is 11. So here what will be the last element? So the left value is something, left value means the starting index will be 0, and the right value will be something. Right value means the ending index will be something which is equals to m into n minus 1. Means in this particular case, what is the value of m? The value of m is 3, the value of n is 4, minus 1, which is equals to 11. That's why you can see that the last index that we are getting here in our question is 11. And how basically we will be able to calculate after getting a middle value, what is the middle element, what is the position of that, we can easily calculate by calculating the row number and the column number. I hope that I'm making sense to everyone. This will be very much clear if you only know the concept of a binary search, otherwise you will be in a trouble. I'm again repeating this point. Now what I will do is that I'll try to do the implementation for the same, and after doing the implementation, I believe that everything will be pretty much clear to everyone. So let me try to open my Jupyter notebook. So what I will try to do now is that I'll try to just show you the implementation for the same. So what I will try to do is that, let me first of all save my file. So this is nothing but we are trying to search in 2D array interview question. Okay. Now here if you will see, let me write first of all the driver code here. So what I will do is that I will take the matrix. I will try to take the same matrix that we are discussing in our example, so that everything will be making sense to everyone. So we are having the elements 1, 3, 5. So let me take all those elements 5 and 7. The next value that we were having was 10, 11, 16 and 20. The next element that we have was 23, 30 and 34 and 60. So this is a matrix that we have. Now what is the target value that I'm expecting? It is 3. Okay. Now whatsoever be the result that we are getting, we are creating a one function name. So here what we can do is that we will try to make a function call. So function calling will happen here. Now what I can do is that I can create one function here, maybe binary search in 2D sorted matrix. It will be too long. Binary search in a sorted matrix. I want to give some meaningful name. Or let me try to give it search in a sorted matrix. Okay. So here what I will do is that I will pass the matrix and I will pass the target value. Now whatever be the result we are getting, we will print that. So either we should get true or we should get false. Now here what I will do is that I will provide the function definition. Can I say? Right? Now here what we can do is that we can just copy this thing and we can say def the function name. And now what we can do is that first of all we need to calculate what is the value of number of rows. So it is nothing but len of the matrix that we have. This is nothing but the number of rows that we have. We can make one base condition that if the number of rows itself will be equal to 0, it means that there is no element which is present inside the matrix. We can simply return false, because whatsoever value you are looking for, if there is no rows in a 2D matrix, then it doesn't make any sense, right? Now if that condition is not satisfying, at that point of time what we will try to do is that we will try to first of all evaluate the number of columns. So here we got the value of the number of rows. Now how we can calculate the number of columns in the Python programming language? It's very simple. Number of columns. So what we can do here is that we can say len of matrix 0. That's it. Right? Now once we will be able to get the number of columns, what we can do is that just like the implementation of binary search which I showed you, I hope everyone remembers. So we need to define the starting index, maybe you can say left, and ending index right side, right? It will be 0, and it will be the right will be m into n minus 1, as I already explained in the blackboard part. Now what we can do is that we can make one while loop which is left less than equals to right. What we can say is that first of all we will evaluate what is the mid value. Mid value will be equals to left plus right minus left by 2. All these things we have discussed, why we are finding out the middle value like this, I have already discussed. Now what we get, we will be able to get the mid index with the help of this. I want the mid element. How will be able to get the mid element? Mid element will be equals to the matrix of what is the row number. How we can get the row? Mid divided by n, number of columns. How we get the column? Mid modulo n. We will be able to get the column. Now what we need to do is that we need to check if the target is equal to the mid underscore element, then we can simply return the value as true. We can simply return the value as true. If suppose the target in elif, what we can type as a condition, now suppose the target that we are looking for is having a smaller value as comparable to the mid element. Now at this point of time, whether I should go towards left or right, when the target value is lesser than the middle element, I should go towards left. When I will go towards left, I will update the value of my right. I will update the value of my right, which is equals to mid minus 1. Correct? In else part, we can update the value of left as mid plus 1. Now suppose if we will exit out of the while loop, still we will not able to get any true statement. It means it will automatically return the value as false, which indicates that okay, the values that you are looking for is not at all present inside your 2D matrix, right? Let's try to run this code. We'll try to see what we are getting. So it is resulting as true. Now what I will do is that, just to see the test cases, what we can do, suppose I will write the number as maybe 33, which is not present. Let's see. So it is returning the value as false. Suppose we will write something like maybe 11, 11 is there, 12, again false. If we type 11, it's true. So basically, if you will see from this part, we are doing only binary search implementation. We are doing only binary search implementation that we already did in our last sessions, last video. I have created one separate video for a binary search implementation part. I remember very well. I hope everyone remembers this part. So if you will try to see the coding portion of binary search implementation and what I did here is exactly same. What's the difference is how you are extracting the elements from the 2D array, right? So basically the row number we are calculating by taking the number of by taking whatever index you are calculating divided by the value of n, where n is the number of columns that we have, and column number is straightforward equals to whatever with the index that you are getting modulo will give you the remainder n. That is the only knowledge which is required to implement this question. If someone knows that how we can extract the row number and the column number from a 2D matrix in order to extract any element, then he or she will definitely give the result within a second. This is a medium level problem, but I think that after listening this explanation pretty well, you will be able to do this particular question. within seconds. It will not take much time to implement the things if you know what is binary search, if you know what is 2D matrix, if you know how we can extract any element from the 2D matrix, then it's quite easy problem, I would say, right? I hope that everything whatsoever we have covered up so far will make sense to everyone. If you still have any sort of doubt, I will for sure share all the materials, whether it be the implementation code or whether it be the conceptual part which I have discussed in this particular class. But if you still have any sort of doubt, do let me know. I'll try to resolve it as soon as possible. With this, happy learning to all. I'll see you all in my next video, where now we will discuss about another searching algorithm called as ternary search. That's also amazing. Again, the major prerequisite to understand that part also is that you should have an understanding of binary search. That's why I used to say that binary search is quite important algorithm, right? With this, happy learning to all. Bye-bye everyone. See you soon in my next upcoming session.